Furnace assembly. The main parts are the furnace, doghouses on each side of the furnace, combustion and pre-combustion tubes, scrubber assembly, pre-scrubber assembly, and the breech block assembly. First, connect the left doghouse to the furnace with these 2 screws. Remove the side cover by unscrewing these 4 screws. Do not tighten the screws completely because the doghouse position will have to be adjusted later. Connecting the second doghouse to the right of the furnace. Protective covers will be used in the end, so we will remove them for now. Remove the side cover as previously explained and use 2 screws to connect the doghouse to the furnace. Do not over-tighten the screws, since the position of the doghouse will have to be adjusted later to be in line with the combustion tube coming out of the furnace. Unpacking and putting together the pre-scrubber. Carefully unpack all the glassware. Unpack the pre-scrubber body, dispersion tube, and the black threaded bushing with O-ring. Place the O-ring over the open end of the dispersion tube and insert this tube into the pre-scrubber body. Adjust the O-ring on the dispersion tube so that the tube is just above the bottom of the pre-scrubber body, and tighten the threaded bushing over the dispersion tube to seal the entire assembly. Place the pre-scrubber in its designated place on the right side doghouse. Combustion tubes. Carefully unpack the combustion tubes. Depending on what type of samples you want to measure, you can use a syringe or ladle combustion tube. For both of those options, you will also need a pre-combustion tube. Unpack the pre-combustion tube. It is filled with barium chromate. Place small unions on both ends of the pre-combustion tube and place it in the furnace like this. Combustion tubes are filled with barium chromate and silver. The exit, silver-filled end of the combustion tube should be to the left, with the tube aligned so the silver is resting over the insulation vestibule at the left end of the heating elements. If you have the components for both ladle and syringe introduction, install the longer ladle combustion tube first. The ladle combustion tube has an offset inlet. The combustion tube should be aligned with the offset on the bottom. Use provided insulation to insulate both ends of the furnace at places where the combustion and pre-combustion tubes are sticking out. Carefully check if the furnace can be closed without putting pressure on and breaking the tubes. If the lid puts pressure on the tubes, remove some of the insulation. Post scrubbers. Use a large union to connect the left end of the combustion tube to the Ballston filter if a syringe tube is used, or to the post scrubbers if a ladle tube is used. Place the Ballston filter on the doghouse, but only for liquid samples with the syringe tube. The arrow should point up. Place magnesium perchlorate or silica gel scrubber to the left of the Ballston filter. Place the acid dichromate and manganese dioxide scrubber to the left from the magnesium perchlorate or silica gel scrubber. Post-scrubber positions and connections are presented on this image. Use small 1/4 inch to 1/8 inch silicone unions and Teflon tubing to complete the connections. Make the lines as short as possible to minimize the gas flow path. Connect the exit of the combustion tube to the inlet bottom of the Ballston filter for liquid samples. Run the tubing through the doghouse using the holes provided. Connect the exit of the Ballston filter to the inlet of the scrubber tube filled with magnesium perchlorate or silica gel. Connect the exit of the magnesium perchlorate scrubber to the inlet of the scrubber tube filled with acid dichromate and manganese dioxide, the NOx scrubber. Connect the exit of the NOx scrubber to the cell inlet tube of the carbon coulometer through a one-way check valve. When finished, Adjust the left doghouse and tighten it to the furnace. Put the side cover back. Breech block. Unpack the breech block assembly box. Inside are the breech block, U-shaped magnet, and small porcelain boats for sample introduction. Slide the breech block support column into the track on the top of the right doghouse. Place the breech block in its support column with the closed end directed toward the right and the inlet to the back. Adjust the position of the breech block and its support in the track so the inlet end of the combustion tube is 1/4 inch to 1/8 inch away from the outside edge of the breech block. Remove the combustion tube and tighten the breech block support in position by turning the support column in the clockwise direction. Adjust the breech block's height in its support column so the combustion tube is level and free from strain. Tighten the breech block in place with the thumb screw on the support column. Recheck the combustion tube alignment. The breech block should not cause any strain on the tube, and the combustion tube should be level. Make necessary adjustments to the breech block and its support column to alleviate any strain. When finished, tighten the right doghouse to the furnace. Connect the oxygen supply from the tank regulator through the lower outside hole on the back wall of the module to the inlet of the flow meter. Connect from the exit, top, of the flow meter to the left end of the pre-combustion tube. Run Teflon tubing through the upper inside hole on the back wall of the module through the tube guide on the back of the furnace to the pre-combustion tube. Connect the right end of the pre-combustion tube to the dispersion tube inlet of the gas scrubber, KOH scrubber. Run the tubing through the lower hole on the back wall of the module and through the hole on the top surface of the module. Connect the exit of the KOH scrubber to the inlet of the breech block using a one-way check valve. Be sure to install the check valve so the flow direction is from the KOH scrubber to the breech block inlet. Put back the side cover. Attach safety shields to the top of each doghouse. Furnace. Use the power switch to start the furnace and the temperature controller to adjust temperature. Temperatures up to 1100 degrees Celsius can be selected to completely oxidize all forms of carbon, or, alternatively, a lower temperature may be selected, 400 to 460 degrees Celsius, to selectively oxidize only organic compounds. In either case, the sample combustion gases are swept through a barium chromate catalyst/scrubber that catalyzes carbon monoxide to carbon dioxide and removes some sulfur compounds. Other non-carbon combustion products such as sulfur dioxide, sulfur trioxide, halogens, and nitric oxides are removed from the gas stream by installed chemical scrubbers. The CO2 is then measured with the carbon coulometer. We'll begin with screen calibration. Follow the instructions on the screen to calibrate. Screen calibration should only be done when users change. Setting parameters. Select System Parameters. Change settings. Here you can choose the form you'd like your final results to be calculated in. If you choose carbon, the results will be presented in the form of %C, % carbon, or you can choose % CO2 or percent CO3. Here, based on the type of your samples, you can choose initial sample measurements entered by weight, volume, or units only. If the units only option is selected, results will be presented as amount of carbon in micrograms. The units range from micrograms to milligrams or grams. Here we choose milligrams. The percent difference criteria is 0.1% by default. This is the number the system uses to decide when to stop. The system takes a sample reading every 1 minute by default, compares the last two readings, and if the difference is less than 0.1%, the measurement stops. Factor is used if you have some diluted or concentrated samples. You can enter a factor here so the system will calculate and give you the final values. Number of readings is the minimum number of sample readings the system will take per sample. In this case, we chose 8, but this number can be any number higher than 2 and lower than 45. This is the number of readings the system will do without using the percent difference criteria. After running this many readings, the system will start comparing the last two results to decide when to stop. Interval is the time in between sample readings. The default is 1 minute, but you can increase or decrease the interval. This will affect total measurement time for a sample. Timing method. If auto endpoint is selected, the system will use previously set percent difference criteria to decide when to stop. If fixed number of readings is selected, then the system will only run the number of readings you selected previously. In our case, we chose 8 readings, so the system would take 8 readings for each sample and then stop. Sampling method. You can choose auto sampler if you have an auto sampler. Otherwise, choose manual if you have a manual acidification unit. Printout format. Choose standard format here. The calibration test format is only used to check if the electronics are working. Sample entry method. Information about samples, such as sample names and weights or volumes, can be entered from the USB disk or manually. Here, Analyst ID and Instrument ID can be changed. This is convenient if you have more than one user. When finished, press F4 to get out. When you press back, the system will save the changes on the USB and return you to the system parameters screen. Print settings. Even if the printer is not attached, you can select this to view the parameter data. Press F4 to get out. Setting date and time. Press 1 to enter the date and press 2 to enter the time. Press F4 to return to the System Parameters page and press back once more to save all the changes on the USB. Preparing the carbon coulometer cell. The cell has 2 compartments. The larger one is the cathode compartment and the smaller one is the anode compartment. There are a few steps to preparing the coulometer cell. Step 1. Place the magnetic stirrer in the cathode compartment. Step 2. Fill the anode compartment's lower bulb with potassium iodide until it is about 1/4 to 1/3 of the way full. Step 3. Using the gallon jug of cathode solution, fill the cathode compartment up to the 100 milliliter line. Step 4. Using the smaller sized bottle of anode solution, fill the anode compartment until it is slightly less full than the level of the cathode compartment. Step 5. Put the tops on the compartments. The cathode top has a platinum electrode and an inlet tube. The anode top has a silver electrode. After putting both tops on, adjust the heights of the platinum electrode and the inlet tube so that they do not interfere with the magnetic stirrer. You may have to lift the electrode and the inlet tube slightly or lower them down if necessary. Both the platinum electrode and the inlet tube should be just slightly above the magnetic stirrer. Step 6. After adjusting the heights of the inlet tube and the platinum electrode, turn the cell to adjust the cathode top. You want the platinum electrode in the inlet tube to be as far away as possible from the light path going through the bottom part of the cell when it's placed in the coulometer. To do that, make sure that the top of the silver electrode on the anode compartment is in between the inlet tube and the platinum electrode from the side angle. This ensures that the platinum electrode and the inlet tube will not interfere with the light path. Step 7. For the final step, take a clean Kim wipe with a small amount of methanol and wipe the sides to remove potential fingerprints or any other residue that will interfere with the light path. Now the cell is ready to be placed in the coulometer. Place the cell into the cell compartment of the coulometer. Before connecting, check that the cell current switch is in the off position. While the switch is off, connect the cathode using the black connector and the anode using the red connector. Then place the inlet tube and the outlet tube through the holder on the right in this case. Now the cell is ready to be titrated. To connect the coulometer and the acidification unit, connect the inlet tube of the cell to the acidification unit with the tubing coming out of the post scrubber. The check valve ensures that the carrier gas moves in one direction, towards the cell. When the cell is placed in the coulometer and connected, the cell current button is still in the off position and the carrier gas is going through the cell, you can go to Run Cell Setup. The system will use this number to determine 100% transparency. You can move the cell slightly left or right to maximize this number. The number should be between 2700 and 4000 and stable within 10 digits. At this time, it is best to leave the system 5 to 10 minutes to stabilize. When the difference is less than 10 digits, press Next. The system will regard the final number as 100% transparency. Titrating the cell. Press Start Analysis. In this step, we'll titrate the cell down. The cell should be at 100% transparency, and the cell current should be 0. Flip the cell current switch to the on position. The cell current should change to 200 milliamps, and the transparency should begin decreasing. The cathode solution will slowly change color and become bluer. The percent T number should decrease to 29.5% plus or minus 0.1. When it does, the titration is complete. While waiting for transparency to decrease, we recommend leaving the coulometer 45 minutes to an hour, even though 29.5 will be reached relatively quickly. This leaves enough time for the system to stabilize. After waiting for this period, the cathode compartment's contents should be blue, percent T should be 29.5, and the system is stable and ready. After that, press Next. Here we can enter how many samples we want to measure. Be sure to include the blank measurement in your number of samples. You can enter all of the samples and their information now, or you can enter them one by one. To enter one by one, enter the first sample and press Next to enter the next sample. For example, we enter 1 and begin the first sample. Remember to always start with a blank sample by selecting blank. Now the system is ready to begin analysis. Running solid samples with the furnace and the coulometer. Remove the capped end on the breech block and insert the ladle. Hand tighten the capped end back. Be careful not to break the combustion tube. Wait for the system to purge any CO2 trapped inside. To start the measurement, press Begin Analysis. Displayed here we have sample name, percent T, cell current, total amount of carbon in micrograms measured, and the elapsed time. Slide the ladle into the combustion tube by using the U-shaped magnet. When using the magnet to manipulate the ladle into the combustion tube, the scoop part of the ladle has to be in the center of the heating zone. When the system is finished with measuring blank, we can use the U-shaped magnet to take the ladle out from the combustion tube. We set the system to do 8 readings, which should take 7 minutes because the first reading is at time 0. When it finishes, we can see that the blank sample is 3.12 micrograms of carbon. Any value between 0 and 10 micrograms of carbon is acceptable, but this range varies between different analysts and types of samples. If you would like to measure more samples, press Next. If you are finished, press Done. This sample was weighed in a porcelain boat, and the boat was placed in the ladle. Insert the ladle into the combustion tube, tighten the capped end, and you're ready to start the next measurement. When the ladle is in place, press Next, enter your sample name and size, and press Enter. We can see that the percent T is slightly elevated because there's trapped CO2 from the air that came inside the system. The system will purge that, and the percent T will go back to 29.5. When this is done, and the cell current is 0, the system is ready to begin analysis. To begin sample analysis, press Begin Analysis and use the magnet to push the ladle into the combustion tube. The system will measure until it reaches percent difference criteria, and then it will stop. At that point, you can use the magnet to take the ladle out and put another sample in when it cools off. When sample measurement is finished, you can see the results on the screen. For this sample, the measured carbon content is 12.04%. The theoretical value is 12.01%, so this is a good measurement. If you have more samples, you can press Next and measure more samples. Or, if you are finished, you can press Done, and then the system will save these results on the USB. Our systems are equipped with a safety button located on the UIC logo. If you remove your USB drive and are unable to see your results on the drive, you can put the USB back and press the circle in the logo to save the last set of measurements again. This function only remembers the most recent set of measurements, so do not run another analysis before checking your results, because then that analysis will be saved instead of the previous one. Placing syringe combustion tube and running liquid samples with the furnace and the coulometer. Unpack the breech block assembly box. Inside are the breech block and luer adapter. Slide the breech block support column into the track on the top of the right doghouse. Place the breech block in its support column with the closed end directed toward the right and the inlet to the back. Remove the combustion tube and tighten the breech block support in position by turning the support column in the clockwise direction. Adjust the breech block's height in its support column so the combustion tube is level and free from strain. Tighten the breech block in place with the thumb screw on the support column. Replace the capped end and external O-ring with the luer adapter. When finished, tighten the right doghouse to the furnace. Attach safety shields to the top of each doghouse. To introduce liquid samples, use the provided syringe. Adjust the volume to 200 microliters. Remove the white cap at the end of the breech block and insert the syringe. After purging, press the button on the syringe to release the sample. Take the syringe out and put back the white cap. Shutdown of the system. When you are finished with measurements or finished for the day, disconnect the furnace from the cell and coulometer, switch off the cell current, and then switch off the coulometer. Remove the cell and dump the solutions, and then clean the cell so it's ready for the next time you do measurements. Switch off the furnace, but leave carrier gas flowing for another 5 to 10 minutes and do not open the furnace until it is cooled off, or else the combustion tube might break. Thank you for joining us for this demonstration from UIC Incorporated.